Section 1.3 is kind of long, so we're splitting it into 2 days, but also I'm going to split it into more videos than that. So just make sure you're paying attention to the title of the videos and you get through both of the videos for today. So the first one, we're going to talk about increasing and decreasing and some other function behavior, and then we'll talk about symmetry in the second video. Okay, so first of all, to determine if a function is increasing or decreasing over an interval, we look at the relationship between any 2 points that are on that interval. So we're using a capital I here for interval, and this says if x1 is less than x2, this implies f of x1 is less than f of x2. Or in other words, if we have, so we'll call this x1, x2. So for any 2 points on that interval, if I have a point x1 that's to the left of x2, the value of the point, the value of the function at x1 is lower than the one on the right. So the left point, lower than the right point. That does have to be true for any 2 points. So I can't take, let's say, a curve like that and say, oh, well, this point is going to be x1 and this one's going to be x2. And since this one is lower, then it's increasing, because that's not true if I were to do x1 and x2 right there, okay? Likewise, the function is decreasing if the left point, f of x1, is higher than the right point, okay? So something like if x1 is to the left of x2, then this point is lower than this point, okay? If you're looking at the graph, this is pretty easy to determine, okay? And then a function is constant on an interval if the values are the same. In other words, if we have a horizontal line for any points on that curve. So we've got pictures here. Function is increasing if it is going, essentially going up, so, and always from left to right. So any 2 points I pick, so they've got 2 points on here, but I could say I'm going to pick this point and this point, or I'm going to pick even like this point and this point that are really close to each other. The left one is lower than the right one, so we're going up, so increasing. And then similarly for decreasing and for constants, okay? And when we talk about increasing and decreasing, it's not often that we ask if a function is increasing or decreasing at a point. Usually it's more about what is the interval where this function is increasing. So if we were to think about like a basic parabola, y equals x squared, which should be familiar with this, if I wanted to know on what interval is this function increasing, I would say it's increasing everywhere to the right on the right half. So I would say it is increasing on the interval from 0 to infinity. Okay? All right, extrema. Extrema is the Latin plural for, the singular for, plural for extremum. But you really don't need to know the Latin, because you could just say it in English and say extremes. Doesn't really matter. Same thing with max and min. You could just leave off the second half of the word. Okay, so a relative max or min happens when we have, so here's our technical definition, says f of a is a relative min if there exists an interval x1 to x2 that contains a such that, it should be an a, that is a typo, sorry. If a is between x1 and x2, that implies that f of a is less than or equal to f of x. Okay, that's a complicated way to say if there is a point and you can find an interval, okay, so like the points immediately to the left or to the right of that point, if they're both higher than the value there, then we have a relative min, okay? Also, that or equal to part is incorrect. Sorry, I didn't catch this when I copied the notes. Okay, so yeah, so sorry, change these in your notes. It should be a is between x1 and x2, and then f of a is less than f of x for all of the other x values. Okay, but essentially, really what we're talking about is, do we have a point that's lower than the points on either side of it? Doesn't matter what happens elsewhere on the graph, only the points immediately to those sides. So like I could have something that does this later. It doesn't matter that this point is lower than this point. This one is still a minimum compared to the points immediately to the left and right. Okay. Similarly for max, if we have a point that is higher than the points immediately to the left and the right, then we have a maximum. Please note that when we talk about having extrema, having a max or a min, we're talking about the value of the function, meaning the output of the function, okay, the y coordinate of the function, not where does it occur. So those are two separate questions and you'll have to answer both. First question is, where does a max occur? That's going to be the x coordinate. And then what is the max? That's the value of the function. That's the output. Okay, and then our informal definitions here, especially if you're looking at a graph, this is an easy way to determine if you have a max or a min. If your function changes from increasing to decreasing, okay, so increasing to decreasing, we have a max. And by the way, that can be a sharp turn or a smooth curve. Like all of these are shown as smooth curves, but it could be something like this. That's still a relative max. Also, let me add, relative and local mean the same thing when we're talking about extrema. So sometimes you might hear me say local or you might see it written, but that would mean, it just means, you know, local to the points immediately around it, okay? And then if a function changes from decreasing to increase, we have a relative min. All right, so we have these examples where we have a graph. Goodness, typos all over the place. And we want to determine these three things. So first we're looking for intervals where the function is increasing, decreasing, and constant, okay? So when I look at this function, I can see the arrow says goes to negative infinity, but it's a constant function because it is a horizontal line. It is neither increasing or decreasing. And then from 0 to the right, the function has any point to the right is higher than a point to the left, so the function is increasing. So the function is constant on the interval from negative infinity to 0, and I'm going to include that. Okay, so use the bracket. And then it is increasing on the interval from 0, but this one's open, to infinity. Okay, and then there is no interval where it's decreasing. Okay, I would suggest that you pause this and try and answer the next one, and then play and see if we get the same thing. So here I'm looking at this graph, and I'm just going to go from left to right and then fill it in the appropriate spot. So here I can see that my graph starts by decreasing as we move from left to right. We're coming down until we get to 0. So it decreases from negative infinity to 0. So open for the infinity to 0. Now, this 0 mathematically, officially can be included or excluded. It's fine to include it here if you put parentheses there. I don't know if Pearson is going to care, but I would not, okay? So the bracket is fine, or parentheses there. And then the function increases from 0 to, and since we're giving intervals, we're giving the x coordinates here. So it increases to an x value of 2. So from 0 to 2, and again, we can use open or closed. It is okay for that 0 to show up in more than one spot because related to the points on either side of it, okay, for the interval from negative infinity to 0, this point is lower than any of the points to the left. It is also lower than any of the points to the right, so it can be included on the increasing interval as well, okay? And then the function decreases again from 2 to infinity. So again, union symbol is fine, or you could use a comma, or just write the word and, doesn't really matter. But do whatever Pearson says if they're particular, maybe a comma. Okay, 2 to infinity. All right, is it constant anywhere? No, it is not. All right, x coordinate at which f has a relative min. Well, let me erase my scribbles here. I do have a relative min right here because it's lower than the points to either side. So at x equals 0, please never just say 0. Like write x equals 0 or y equals 0, depending on which is appropriate, okay? And that's true for any types of points that you're identifying. And then relative min, so now this is the value of the function. So what is f of 0? It is 0. So I'm going to put f of x equals 0. Or you could say, if you could just give the ordered pair 0, 0, and that would be fine as well. X coordinate at which f has a relative max, that's this point right here. So that's at x equals 2. And then the relative max of f, if you put y equals, that's fine as well. Here, I'll put y equals for this one. Y equals, and then the value of the function there is 4. So the max is 4. Okay, once again, pause it, try it, and then come back and see if we get the same thing. So here I can see the function increases, decreases, increases. So I'm going to say increasing from negative infinity to negative 1, union positive 1 to infinity, because that's this interval and then this interval. So then it is decreasing on the interval from -1 to 1. Again, open or closed, I don't care. X coordinate at which f has a relative min. So we have a relative minimum right here. This point's lower than the points to either side, so at x equals 1. Relative min, so the value of the function would be y equals, what does that look like? Okay, so this is not on an integer value. It kind of looks like -1/2. I'm going to double check by actually just plugging it into the function. So f of 1 would be 1 cubed minus 3 times 1, which is -2. And as I do that, I realize that the scale here is not by ones. So it does make sense that it is between here and here, because that would be all the way down at -5. All right, so -2. Okay, x coordinate where f has a relative max. That appears to be right here at positive or at -1, and then if we plug -1 into that function, we get -1 cubed is still -1, minus 3 times -1 would be +3, so +2. Oh, didn't write the x. X equals -1. F of -1 equals 2. So there's our relative max.